Deep inside a mountain, a machine spins fast enough to power an entire city, non-stop. This single turbine weighs more than 400 tons, heavier than a fully loaded jet. But here's what nobody tells you. Building one takes over a year, and one flaw can be catastrophic. Today, we're going inside the world's most secretive turbine factories to see how it's really done. It begins not with metal, but with mountains, raw or torn from the earth thousands of miles away. Most people never think about this. The steel in a turbine starts as dirt brown rock, not shining metal. And what happens next surprised even experienced engineers. This rock will be transformed into something almost indestructible. Stick with us, because this journey spans 3 continents, 6 countries, and one impossible engineering standard. It starts in Brazil's Carajas mines, home to some of the richest iron ore deposits on Earth. This will run 66% pure iron, some of the highest grade rock mine anywhere in the world. From there, it travels nearly 600 miles by rail to reach the coast for processing. But raw iron alone won't survive underwater for 50 years. It needs help from rare alloying metals. Chromium comes from South Africa, nickel from Indonesia, molybdenum from Chile, 3 continents, 1 alloy. Here's what nobody tells you. This exact alloy mix is classified information at most turbine manufacturers. Once combined, these metals are shipped to a steel mill and melted at over 1,600 degrees Celsius. That's nearly 3,000 degrees Fahrenheit, hot enough to vaporize a person in seconds. The transport alone costs manufacturers over $2 million per shipment of raw alloy steel. And mining this much or scars the land. Some pits stretch wider than entire city downtowns. Engineers say the environmental cost is real, but so is the clean energy this metal will one day produce. But before this steel becomes a turbine, it must survive one of the most violent processes in manufacturing. The molten steel is poured into a giant mold, cooling into a rough shape called a casting. It cools for nearly 48 hours, dropping from 1,600 to under 200 degrees Celsius. Once cooled, a robotic arm grinds away rough edges at 12,000 rotations per minute. You can hear it before you see it. A deep grinding roar that shakes the factory floor. Next, the blade moves to a 5-axis CNC machine, carving surfaces accurate to 1/10 of a millimeter. Metal shavings curl off like ribbons, each one a fraction of a hair's width thick. Think about this. One wrong micron here could cause total turbine failure years later underwater. After machining, welders join individual blades to the central hub using submerged arc welding at 400 amps. The weld must hold under 20,000 tons of hydraulic force without a single microscopic crack. And this is where it gets truly extraordinary. The whole assembly is heated again to relieve internal stress. This heat treatment runs at 650 degrees Celsius for 8 straight hours, then cools slowly. Only then is the surface polished by hand, smoothing every curve to a mirror-like finish. But even now, one final test could send this entire turbine back to the furnace. Every blade now passes under a 3D laser scanner, checking accuracy down to 20 microns. That's thinner than human hair, a tolerance most industries would call impossible. An AI vision system then scans for microcracks invisible to the human eye. Roughly 3% of all castings fail this stage and are sent back to be remelted. Every approved turbine must meet ISO 9001 and International Hydropower certification standards. Before shipping, the runner is spun on a test rig at full speed, sometimes over 600 RPM. Vibration sensors monitor every rotation, detecting imbalance smaller than a single gram. But here's the twist. Even with all this automation, one final check still relies on a human hand. Veteran machinists say they can feel a flaw that no sensor has ever caught. Once approved, the turbine is disassembled into sections small enough to transport by rail. Every year, the world manufactures enough hydro turbines to generate over 400 gigawatts of power. That industry is worth more than $30 billion a year and still growing fast. China lead production, followed by Austria, the United States, Japan, and Germany. Nearly 200,000 skilled workers build these machines across the globe today. The first modern hydro turbine was installed in 1882, and some are still in use today. In the last 50 years, turbine efficiency has jumped from 70% to over 95%. Did you know one large turbine can power over 300,000 homes at once? Did you know some turbine blades are cast from a mold used only a single time? And did you know the largest turbines ever built came from the Three Gorges Dam project? Over the next decade, demand for these turbines is expected to double as clean energy grows. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.